Triclosan and Plankton, oh my, with the presenter, Jillian Love. Oh, thank you, Mr. or Mrs. Moderator. I don't know who you are yet, but thank you. And while I'm thanking people, I'd like to thank Mr. Dutton, Mr. Diesla, and Dr. Lund for providing expertise and information in their area. You're smiling and it's making me laugh, Riley. My parents for putting up with every aerator that I had on in my house, Riley Brown, Breanne Blyden, and Madison Perkins for helping me collect data and also to record this very presentation. The audience for coming to listen to me today. I know, ramblings of like a 12th grader. And my fellow Governor's School students for giving me encouragement when I needed it. So some key points before I dive into my project. Over 206 million pounds of chemical waste is dumped into U.S. waterways per year. They can be found in everyday items like soaps, detergents, and toothpaste. And these chemicals have been known to cause diseases in humans and other animals, and also to cause disruption in the hormonal system for humans. And because of that, I came up with my question of what are the effects of triclosan, one of those chemicals being dumped into U.S. waterways, on algal density and the Potomac, Rappahannock, and Elizabeth River. So some backstory, I've always wanted to be a doctor. That has been my dream, and it probably always will be until I become one. And while I was taking a shower one day, I mean, that shower was really short, but anyway, I turned over the bottle and I saw that it had triclosan on it. And I really wondered what that was, so I looked up some quick facts about it. It's C12H7Cl3O2. And as you can see, it has its own little chemical structure there that I'll probably make bigger for the human populace to see, Mr. Dutton. It was patented and made in the 1960s, and it has a 60 to 100% detection rate in U.S. waterways. What's wrong?
Nothing. Keep going.
Okay. It works by blocking the active site of a fatty acid protein it's an enzyme needed for synthesis in bacteria and plankton, and that pretty much means that they can't create their outer wall to protect themselves. However, it has been known that bacteria can become resistant to it, which is why we don't use triclosan as much in soaps anymore. And it has been shown to have an effect on human hormones in multiple studies. And so I wanted to know what this says to plankton, because I see them as the bottom of the trophic level. Whoever eats seafood, eventually that seafood ate plankton, and it gives us oxygen. So if plankton gets sick, the earth will get sick and humans will get sick. So I picked out 3 locations to do this study: the Potomac, the Rappahannock, and the Elizabeth River. And my variables were triclosan, because I had to kind of use it for it to be a study on it, in different concentrations at 0, 0.2, 0.4, and 0.6 grams, which was then diluted into 100 milliliters, and the 3 rivers, the Potomac, the Rappahannock, and the Elizabeth River. And my dependent variable was algal density. So I made a couple of assumptions by looking up report cards on the rivers from the past and from today. In the past, the Elizabeth River was practically dead. It had an F on its report card in 2011, and it was dying. There was little to no life. Pollution was a major problem, and today it is now ranked out as C. The Potomac River wasn't failing, but it was getting pretty close to it, and it did have a couple of pollution problems, and it is again ranked out as C now. And that could again be because of how large the Potomac River is. It is one of the largest rivers in the Chesapeake Bay and has multiple rivers draining into it. And finally, the Rappahannock River had a D+ in the past, and it now has a C as well. So it's doing a little bit better than the Potomac River. As you can see from my sites, here's where I took my data from on the Elizabeth River. There are man-made structures on almost every site that I picked to do, just so that I had a little bit of consistency. This is known as Bay Street, and that's because you're on the Chesapeake Bay whenever you walk along it, which is where I took my data from. This is the Potomac River Bridge and an aerial view. You can see some areas of pollution surrounding it, and I know you can't see it within this picture, but there are multiple sandbars and other constructions and areas where they have to fix the bridge and whatnot that cause pollution within the area. And finally, in Tappahannock, this is St. Mary's, and I took my data just over here on the stalk, and this is the aerial view. So my hypotheses were that the Elizabeth River would have the most algal density because of the fact that it faced such high pollution in the past, and the Rappahannock River would have the least algal density after adding triclosan because of the fact that it had the best pollution overall when compared to the other two rivers, meaning that there was very little in standards of the other two. And finally, for triclosan, I had that the more triclosan was added, the least, smaller algal density there would be. So the first step to my project was I took a plankton tow, and I towed plankton for 5 minutes in every river, collecting 100 milliliters of water. I then added mineral water, 100 milliliters of mineral water, to help keep the plankton alive until I could get it into artificial light and help it sustain itself a little bit and keep it alive, which is what is shown here. This is artificial light shining down on mason jars with foil surrounding it to make sure that every mason jar got relatively the same amount of light or light at all, and that it was distributed correctly. I then waited 1 hour for everything to settle, and I counted it. I don't know why it's going so fast, but I counted it. I took a 10 milliliter sample and I put it on a petri dish, and I counted it using this diagram, I guess I could call it. I feel like I could have a better word for it, but I use this as kind of like a stencil, and I counted the algal density within each centimeter square, and then I multiplied it by 20 to get the algal density under 40 times magnification. Then I added triclosan, and that was again diluted in 100 milliliters of water. I then placed them back under the artificial light and waited another hour and took a 10 milliliter sample again, then counted them with the petri dish, I will get that right eventually, and then multiplied the density by 30 to get how much was in the jar. So my assumptions were that the Elizabeth River would have the most algal density and the Rappahannock River would have the least after adding triclosan. But in reality, they were way more similar than I expected them to be. And that's okay. That doesn't mean that they didn't have an effect on algal density. It just means that they were more similar at level C than I assumed. So the before didn't matter, the after did. The fact that the rivers have been improving means that the triclosan had a less of an effect on the algal density than I assumed in each river. And as you can see, the p-value was high and therefore didn't have a significance on the effects. But again, that is okay. That means that I was wrong. I had to reject my null hypotheses, but that also means that the rivers are similar, and that means if we improve the river health, we'll thereby be improving algal density and algal health, because it will be helping them produce more and become more frugal, which is important because, again, humans get sick, algae get sick, we die. That's really horrible, but that's the best way I can think about it, because over time that is what will happen. However, triclosan concentration did have an effect on percent change. If you look here, there's a negative trend going all the way down. Here are the p-values showing that it did have an effect. And if you look, I mean, there's very little to no error. What little error there was in calculations or in any other form of my study. And the fact that it went down to such a great degree and that changed so much shows that triclosan does have an effect on percent change. So if you were to put triclosan with algae, it will eventually have an effect if the river health isn't as good as it should be. So triclosan concentrations in each river also caused a negative trend. It was just a little bit less because of the fact that each river had the same ranking. So keeping that in mind, that means that triclosan is bad for algae. It should not be near algae anymore. But if we continue to improve the health of each river, we will not have to worry about it as our main concern, and we can rest at ease that we are not becoming hormone destroyers and we're destroying our own bodies with this chemical. And again, it didn't matter as much as I thought. And so that means that we can look to the future. If we improve our rivers, we improve our lives, and we improve the lives of algae because they aren't dying as much and they aren't becoming resistant. And so they aren't doing things like not dying when they should be dying and staying alive and causing algal blooms. And they're also not dying for no reason and causing a ranking like an F on a report card like the Elizabeth River did in the past. So thank you for watching. Mr. Dutton, bye-bye. You're going to have so much to say and you're going to punch me in the face, I know it. Bye. I love you so much. I miss you so much. I really didn't, but you know I did.